The invent and simplify answer that sounds great, but fails the bar raiser. Most candidates answer this question with a model architecture and bolt caching on at the end, which tells every bar raiser in the room that you have never had to defend a latency SLA in production. The question is, how would you design a system to serve personalized search rankings to 500 million users with sub-100 Mbps P99 latency? The LP being tested is invent and simplify, which at Amazon means finding elegant, production-viable solutions that reduce complexity without sacrificing reliability at scale. What the bar raiser is actually listening for is whether you treat sub-100 mirrors P99 as a hard constraint that shapes every design decision you make, or as a footnote you address with a caching layer at the very end. Here is how most candidates answer the 500 million user search ranking question.
I would build a 2-tower model, 1 tower for the user, 1 for the item, trained on historical click data. At query time, I would run approximate nearest neighbor search using FAICES to retrieve the top candidates, then pass them through a ranking model. To handle latency, I would add a Redis cache for popular queries and pre-compute user embeddings nightly. The ranking model would be a lightweight gradient-boosted tree to keep inference fast. This should comfortably handle 500 million users if we scale the serving fleet horizontally.
Latency treated as afterthought, cache and fleet scaling added last. No retrieval, genre ranking budget split. P99 constraint is unquantified. Pre-compute cycle is daily. Personalization, freshness, risk unaddressed. No graceful degradation path when latency budget is exceeded. Here is what I am writing in the debrief right now. Item 1. Latency constraint named but never used to drive architectural decisions. Item 2. No explicit latency budget split between retrieval and ranking stages. Item 3. Daily pre-computation proposed without acknowledging personalization freshness risk. Item 4. No graceful degradation strategy when P99 budget is breached at scale. Verdict: does not demonstrate invent and simplify. Same question. Watch how this candidate lets the latency constraint drive the entire architecture.
Sub-100 meters P99 is the first constraint I design around, not the last. I would split the budget, roughly 20 millimeters for 2-tower ANN retrieval over a pre-built FAICE index, and 60 millimeters for a lightweight ranker, leaving 20 millimeters for network and feature serving overhead. User tower embeddings are pre-computed and pushed to a low-latency feature store refreshed every 15 minutes, balancing freshness against compute cost. Popular query results are cached with a TTL tuned to query frequency. If retrieval breaches its budget, the system falls back to a pre-ranked static set. The user still gets a result, just a less personalized one. I would instrument P99 at every stage boundary so we catch regressions before they compound.
Latency budget decomposed explicitly across retrieval and ranking stages. Freshness versus compute trade-off quantified. 15-minute refresh cycle justified. Graceful degradation path named and scoped to the retrieval stage. Instrumentation plan proposed proactively. Shows production ownership instinct. Notice what changed. Latency stopped being a feature and became the skeleton of the whole design. Item 1. Decomposed P99 budget into per-stage allocations before choosing any model. Item 2. Articulated freshness versus compute trade-off with a concrete refresh cadence. Item 3. Named and bounded a graceful degradation path. Production ownership signal. Item 4. Propose per-stage instrumentation proactively, did not wait to be asked. Verdict: strong signal, raises the bar. Before your loop, run your answer through these 3 questions. Question 1. Can you split your latency budget across every stage before naming a model? If not, latency is decoration, not a design constraint, and the bar raiser will hear it. Question 2. Have you named the freshness versus compute trade-off for your personalization signals? If not, Your pre-computation story has an unacknowledged production risk sitting in it. Question 3. Do you have a graceful degradation path when the latency budget is exceeded? If not, your system has no floor. And at 500 million users, the floor always gets tested. If you cannot answer yes to all three, you are not demonstrating invent and simplify. You are describing a research prototype, not a production system. How do your real stories score? Get a personalized report scored against the interview rubric Amazon uses for MLE candidates, including how your system design answers land against invent and simplify. Find it at interview101.com.